Okay, so number 8. Number 8 is definitely a calculator problem. You would never have to worry about doing that thing by hand, but getting it into the calculator can be a little bit tricky. So I'm going to show you. I already put the function in and tested it to make sure that I put it in right. But remember, you can't put like sine to the 4th times 2x or of 2x in your calculator the way you see it here. So how you enter that function is as follows. The 2 in this function is not being raised to the 4th power, so make sure your 2 is outside of the parentheses. Then the sine of 2x all raised to the 4th. Why? Because remember that the sine squared of x can be written as the sine of x squared. So I'm just using that idea to help me with the calculator. Okay, so you're going to have to use a lot of parentheses and you're going to have to be really careful here. And that's why they put this problem, which is just stupid. It's kind of a nightmare, but they want to make sure you can use the calculator. So it's 2 times the quantity sine of 2x all raised to the 4th minus 3. So let me just arrow over here a little bit. There it is. Minus 3 times, again, it was the sine cubed of 4x. So we write the sine of 4x in parentheses cubed. And when you graph it, you're going to get this graph here. Now, I want you to be really careful because the interval that they're giving you is from 0 to 0.7, and neither one of those endpoints is inclusive, right? If they were inclusive, you'd have these square brackets, but they're not. They're rounded brackets. So this, you know, let me change my window, say from 0 to 0.8 in the x direction, and hit the graph key and see what happens. So you're going to have a 0 here, but since 0 is not included, you wouldn't count it. So this is the 0 I'm curious about. So we're just going to do second calc 0, and we'll go a little bit to the left, hit enter, go a little bit to the right of that 0, hit enter again, hit enter one more time, and it looks like the value of x is at 0.5672-ish. Okay? So again, don't forget, pay attention to the way the intervals are written. If they're the square bracketed intervals, then you would include that other 0, but these were rounded to begin with, so that means that the endpoints are not inclusive. So the answer choice here would be, I guess D would be the best answer choice for that one there. Now in number 9, we're using the same function. So remember, this was the derivative function, and so when we want to know when the tangent line, when the line is tangent to the function f, we don't know what f is, but we do know that when the derivative equals to 0, then that's the point, the x value, on the graph of f where that tangent line would be, horizontal or flat. I hope that makes sense. If not, let me know and I'll say it a different way or better. Number 9, at which x value over the interval from 0 to 2, now see 0 is not included but 2 is, does the graph have a relative minimum? Refer to the graph of f prime. Well, we use the graph of f prime, so let me just change my window. I'm going to go from 0 to, I always like to go a little bit more than the endpoint, so 0 to 2.1. I'm going to hit enter and I'm going to graph that thing, and since it's a strange function, it's going to get a little bit weird. Okay, so when do we have a relative minimum? We know we're going to have a relative minimum on the graph of f where the graph of the derivative goes from negative to positive. Well, that occurs here, and this is 2 here, or this is 2, but this is 2.1, so it's only going to occur right here. So if I do second calc 0 to find that value, I'm going to go a little to the left, press enter, go a little to the right, press enter, and press enter one more time, and it looks like it's still at this 0.567. Is that right? Does the graph of f have a relative minimum? So it looks like, again, it's at 0.567. I don't know if that's right. I'm going to think about this one for a minute, but we know that the relative minimum occurs if we're looking at the graph of f prime, when f prime goes from negative to positive, right? So here's our x value. If it's negative, if the derivative's negative, then that means the function's decreasing, and if the derivative's positive to the other side, it means the function's increasing, so we're going to have a relative minimum. And the relative minimum has to occur at that x value, and according to my calculator, it's 0.567 again. So I guess it would be E, but I want to think about that a little bit more. So if I have a revelation, I'll let you know on that one. All right, looks like I have to print out another page. So I'm going to stop this video and I'll continue on in a second.